Hi all, this lecture is critical. Do you still remember the transition from your primary school to middle school? In your middle school, you learn algebra. At that time, you are accustomed to set up variables and list equations with variables, and then solve the variables. In this lecture, we will continue the journey, which means after you set up any variable, current or voltage, we will list equations and solve the variable. Let's start it. Hello everyone, this is lecture 4 of PEC. In this lecture, we will talk about the reference directions. Firstly, we need to answer a question, why do we need a reference direction? According to your circuit knowledge learned from the middle school, you can know for such a circuit, the current must flow in this way. It's very simple. But as we've discussed in lecture 1, for some circuits, the real direction of the current or the voltage cannot be determined in advance. For example, we can think there's an element on every line of the circuit. Furthermore, the directions of the currents of these elements can be determined because the left voltage is higher than the right voltage. But for the element in the middle, its current direction cannot be known in advance. We've talked about it in lecture 1. The second reason is that sometimes the direction of an element's voltage or current changes with time. That is sinusoidal stimulation. Now let me show you an on-site experiment. This is a demonstration experiment of a sinusoidal signal. Firstly, I will introduce you the experiment equipment we used. This experiment and the following ones are all carried out on the movable circuit experiment box. It's specially designed for teaching by PEC teaching group of Tsinghua University. It can be divided into 3 parts. The first part is a signal generator, which can generate the sine wave signal or the square signal. The second part is the circuit board. The upper circuit board, which is already made, can be changed to demonstrate different experiments. The lower breadboard can be used to build circuits on yourself. The box provides plus 5 volts and plus minus 12 volts voltage source. The third part is a virtual instrument. It connected to the computer via USB port. It can use LabVIEW software to realize a 2-channel virtual oscilloscope and a function generator. Let's demonstrate experiment. The circuit is made up of 2 resistors of 30 kilo ohms in series. The input is a sine wave. It connected between the input port and the reference port. The output is the voltage of the lower resistor. Now you can see they are input and output voltage waves displayed by virtual oscilloscope. The channel 1 is the input signal, is a yellow wave on the screen. The channel 2 is the output signal, is a green curve. From the waves you can see, firstly, the sine signal is changed with time. Secondly, the value of the branch variable and the current can be plus or minus when they are changed with time. In other words, their real direction is changing all the time, so it's necessary to introduce the reference directions. Since you've known the need for reference directions, let's discuss the direction of the current and the voltage respectively. For current, if we define its reference directions as from left to right, and its real direction is from left to right too, then the calculated current with the reference direction must be larger than 0. As to how to calculate it, we will cover this topic in the following lectures. And if the real direction of the current is from right to left, then the calculated current with the reference current must be less than 0. After learned the reference direction, we can see that there's 2 ways for representing reference directions of currents. One is arrow, as the figure shown from left to right or from right to left. The other one is double subscript. IAB represents the reference direction from A to B. Let's do an exercise. For such a simple circuit, we know the real value of the current is 1 ampere, and its current direction is from A to B. If we define the reference direction of I1 as from A to B, it's obvious that I1 equals I and equals 1 ampere. But if we define the current as from B to A, it's easy to get from the simple equation that IR equals negative I equals minus 1 ampere. After discussing the reference direction of the current, let's discuss the reference direction of the voltage. Similarly, if the real voltage of the left is higher than that of the right, and we define the reference voltage of the left is higher than the right, we must get a U which is larger than 0. If the real voltage of the left is lower than the right, and we define the reference voltage of the left is higher than the right, we must get a U which is less than 0. I need to point out again that how to calculate the voltage will be discussed in the following lectures. Let's do another simple exercise. We know UAB is 10 volts, which means A is 10 volts greater than B. If we define the reference direction as upper point to be positive and lower point to be negative, then UA equals UAB equals 10 volts. Of course, we can also define the reference direction as upper negative and lower positive, which means the potential of the lower point is higher than that of the upper point. For this situation, according to the definition of voltage, it's obvious that U2 equals negative UAB, which is minus 10 volts. For the reference direction of the voltage, we have 3 ways to represent. The first one is arrow. It means that the potential is dropping with the direction of the arrow, or there is a drop of the voltage in the direction of the arrow. The second way is positive and negative. We think the potential of the positive terminal U is U volts higher than that of the negative one. The third way is double subscript. We think UAB represents the potential of A is UAB higher than that of B. And then let's review 3 ways for representing the electromotive force. Remind its definition is different from the voltage. According to the definition of the electromotive force, we know the potential is increasing in the direction of the arrow. If it is represented by positive or negative, the potential of positive terminal is E higher than that of the negative terminal. If it's represented by double subscript, it increases from potential B to A is EBA. So you need to compare the difference between the ways for representing the voltage and the electromotive. In the last part of this lecture, we will discuss the relationship between the reference directions of the current and the voltage. For any two-terminal element in the relationship between its reference directions of the current and the voltage could be one of the 4 conditions. I draw them out here. The voltage may have 2 directions, left positive and right negative, or left negative and right positive. The direction of the current may from left to right or from right to left. For these 4 conditions, is it possible to divide them into 2 groups? Pay attention to please. What's the common characteristic of the upper group? What's the common characteristic of the lower group? Yes, in the first group, the current always flows into the positive terminal of the voltage. In the second group, the current always flows into the negative terminal of the voltage. For the first condition, we define it as the associated reference directions. For the second condition, we define it as the non-associated reference directions. The directions of the voltage and the current is appointed as you like, but once you've appointed the reference directions of the voltage and the current in any two-terminal element is associated or non-associated. For a two-terminal element, it's critical to judge the reference directions of the voltage and the current as referenced or non-associated, which plays a decisive role in listing the element's equation. Okay, this is the end of lecture 4.